All right, now some relationships are deterministic. Some are statistical. So in this case, the amount of inches, if you know the feet, is deterministic. You're only going to get one answer when you apply an operation to the feet. So whatever C is, it's 6 times 12, right? So when you have 6 feet, you're always only going to have 6 times 12. So this relationship is deterministic, right? And that means that we have this formula, and any number we multiply 12 is always going to produce only one result. We're not going to get 6 different results when we do 6 times 12. So this is deterministic. Some relationships are statistical. So you might have a scatter plot of the relationship of the atmospheric pressure to the temperature, right? And there might be a trend. There might be a trend of higher temperatures when the pressure increases, but that's not deterministic. Some areas of the globe might have a higher temperature on average for the same pressure. Some may be lower. So there's no way you could find some formula that touches all these dots. The only thing we can do is kind of average trend line and use that to address the relationship. But this relationship is too complicated. It's not deterministic. Okay? And so when we have a relationship that is deterministic, we call that a function. Now, the word function is thrown around a lot. The technical meaning of function mathematically is a relation when every input produces one and only one output. So whatever operations you're doing on the input values are always consistently producing exactly the same unique output. All right? So we want functions to be consistent. Every input produces only one output. Now the range would be the outputs, the y values, the results that you get when you do the operations on the inputs. We call the range variable the dependent variable. And we usually graph those on the vertical axis. The domain, those are the x's. Those are the input numbers. So we're going to do the operations on the domain. And whatever variable we use for the domain is called the independent variable. And those are usually plotted along the horizontal axis. Okay, now we're going to look at that a little bit right here. We'll just do these first two. We don't need to do all this to get the idea. And so the idea here is we want to look at the table values given to us and decide if the answer to these questions are yes or no. And the way you read this is the range is on the left, a function of the domain on the right. The output is a function of the input, right? So you can think of this as if you press a Coke button on a soft drink machine, you input pushing button, you better output always Coke. If sometimes you get a 7-Up or Dr. Pepper, then the input pushing the button does not have a consistent output. So the getting the Coke when you push the Coke button is not a function of pushing the button if you get inconsistent results. So we want consistent results from the domain values showing up in the range values. Okay, so is A a function of B? So B is the domain. And the operations we're doing on the B numbers are producing the output range A numbers. Okay, so I'm going to ask a random person. Let's see, Evan, do you think A is a function of B?
Can you say the question one more time?
Do you think A, number one, do you think A is a function of B?
No.
No, okay, so why are you not, what's your reasoning?
Because for A, all the numbers are positive and
Okay, all
like
the numbers are
close to each
positive?
other.
Okay,
And
all right.
for B, like some of them are positive and some of them are negative.
Okay, well, you know, on a parabola, right? Some of them are
Yeah.
positive and some are negative, but still a function. When you square 2, you always get 4. When you square -2, you always get 4, right?
Yeah, but there's a 5 in there. And
Okay, so notice that the B input, we're not repeating any input values. So when we have a 2, the operations always produce a 1. When we have a -2, we're always going to get a 1. When we have a 5, we're always going to get a 2, right? So 6, we're always going to get a 3. 8, we're always going to get a 5. So you got to look at the relationship. The domain points to the range. There's no repeat values. So this is automatically a function because no repeats, there's no way we can have any inconsistency. Just like a Coke button, you might have 2 buttons, you might have a 2 and a -2 that both produce a 1. So as 2 buttons on the machine, if you push them, can still get you a Coke. The issue is if this 5 was a 2, then we would have 2 outputs when X is 2. That's the issue.
Okay.
Okay, and that's why we do this, because this is subtle and it's easy to get confused. Okay, so we'll look at number 2 and then we'll take a break. All right, so 2, is B a function of A? The range B, a function of domain A. So domain A, numbers, operations on the A producing outputs in B. Okay, let's see. Donovan, what do you think? Is B a function of A?
Here, wait, my bad, I was muted. Can you repeat the question?
Number 2, is B a function of A?
Yeah.
Okay, so let's look.
So.
What? Okay, so notice that there's 2 1s. So for the 2 input values of 1s, the output numbers are different. Whatever operations we're doing to A, when the input is 1, we're getting 2 different results. So this can't be a function. B cannot be a function of A, especially when A is 1. Which answer do we pick? Sometimes it's 2. Sometimes it's -2. So this is statistical. Maybe 50% of the time you get a 2. Maybe the other 50% of the time you get -2. Maybe it's 20-80. You don't know. This is inconsistent. When we do an operation on 1, we're not really sure what answer we're going to get. There's some inconsistency here. Okay, so if the input value, like number 1, there was no repeats, it's automatically consistent. If the input value, like number 2, there is repeats, check to see the outputs are the same. If you have repeated input values and the outputs are different, like they are here, not a function. That's the key. Okay?
So is domain is like another word for input? Could you say that?
Domain are the values that you put into the operations. So that's why I'm using them both, because it's helpful to hear the different words. Yes, same. Anybody else have an issue?